Alright, so the next idea that we are looking at is alcohols, and this is probably the second last thing, or probably third last thing that we're going to be studying in organic chemistry. And the idea basically is, again, it's the same thing that we did in alkanes and alkenes, and the structure is going to remain the same basically as long as the organic goes. So let's draw an alcohol molecule, and see how does this work. So this is a simple structure for an alcohol molecule, and the difference is this. You see, here now you have an OH molecule. So alcohols are basically compounds, organic compounds that has an OH molecule attached, and that OH molecule here is this one. This OH makes this molecule an alcohol molecule, right? And that's the idea. So anytime you see a molecule which has an OH attached, now when we go into carboxylic acid, so you're going to have a structure looking like this. This is acid, this is not alcohol, okay? This is acid, this is carboxylic acid, so there's a difference between them. Right? So whenever you see OH attached like this, you're going to know that this is an alcohol molecule, and then it's going to follow those properties. Now let's talk about the homologous series again, and let's just quickly get over that because we have studied this for a very long time. We studied this in alkane and alkenes as well. So there are four main things that we study in the homologous series, and one of that is that all of these things are going to have same chemical properties. Okay, and the right word is not same, the right word is similar chemical properties, which means that the reactions they undergo, so the reaction of alcohols, or you can say all the reactions that alcohols are going to undergo, those reactions are going to happen more or less. Alcohols are going to react the same way, right? They're reacting structure, just like we studied in alkenes, that alkenes react in a similar manner, so alcohols also react in a similar manner. And if I talk about the other thing, which is same functional group, now I think you should be able to understand that every group of organic molecules that we are studying, alkanes, alkenes, and alcohols, and later on the others as well, they all have an individual homologous series. So the main idea of the homologous series is that which is based on these 4 points, that these 4 points within that individual series remains the same, but the series itself is different. So for the series of alcohols, the same functional group means all of the alcohol molecules are going to have an OH molecule. If I were to talk about alkenes, now alkenes has a single carbon-carbon bond. If I talk about alkenes, you're going to have a double carbon-carbon bond, right? So this is basically what this is all about. So we have two things: similar chemical properties, same functional group. The third thing you have is each molecule, you're going to say, in the next member of the series. So let's say I can draw a few molecules here. Let's say I draw a CH3OH, and I can take the next molecule as well. Now this is basically methanol, we'll get in the naming as well. So this is CH3OH, and then we also have, let's say, the other molecule in the series is CH3CH2OH. And what do we say? That each member in the series is going to differ by an additional CH2 units. Okay, which means that every time you go down the series, every time you go to another molecule, the next molecule in the series, in the homologous series, you will have an additional CH2 unit. And how can you prove that? Now here you see you have 4 hydrogens and you have 1 O and 1 carbon, right? If you see in this one, now you have how many 4, this is 5, and this is 6, right? Yeah. So this is 6 hydrogens, this is 2 carbons, and I've got 1 oxygen. So you see, what's the difference? A difference is 2 hydrogens and 1 carbon, which are added. 1 carbon. So that's what is all about. So every member of the series differs from an additional CH2 unit, right? So these are 3 points. Now the next point is that the physical properties changes gradually down the series. Again, what is included in the physical properties? You talk about the melting point, you talk about boiling point, okay, you talk about solubility, and you talk about viscosity. I think, yeah, these 4. Okay, so as you go down the series, the melting point and the boiling point are going to increase. So this is one thing, as it said, that there's going to be gradual change as you go down the series. So as I go from this molecule, as I go from this methanol molecule to this ethanol molecule, the melting and the boiling points are going to increase. Okay, and now we'll get into solubility and viscosity when we go into physical properties, but this is the general idea of the homologous series. Okay, so that's how the homologous series works, and that is what you need to keep in mind. And now at best, what they're going to do, what they're going to ask you basically is that they'll ask you to tell some characteristics of the homologous series of alcohols, or some characteristics of the homologous series of alkenes or alkenes. They can ask you anything, and the characteristics that you need to know are going to remain same throughout every homologous series. Individually, every homologous series is different because you have different molecules as alkenes, alkenes, and alcohols, but on a broader basis, it remains the same. Okay, everything, like all of the homologous series, or you can say all of the organic molecules, follow these 4 points in their homologous series, all of them. Okay, so this is the idea. Now, one more thing that I'm going to cover in this video is the general formula for alcohols. Okay, and we have seen the general formula for alkenes, and general formula for alkenes is a bit different from them. Because why? Again, we have an OH molecule, so there is an addition of an OH. So the way this works is that is CnH2n plus 1 and an OH molecule. So this is the general formula, and again, the rest of the things are same. So the N here stands for the number of carbon atoms in the molecule. Okay, so let's say if you had the value of N is 2, what are you gonna do? Again, you're gonna place the value of N in place of N. So this is 2 plus 1 OH, and you're gonna have C2. This is 2 into 2, that's 4 and 5. So this is, sorry, I wrote 3. Yeah. Mhm. Okay, so this is C2. This is H4 plus 1 OH. So this is C2H5 OH, right? And you can solve it. So whatever the number of carbon atoms that you have, you can just put in the value here, and you're gonna figure out the value, or you can say you're gonna figure out the formula. All right. So this is the idea. Yeah.